Hello, IB environmental students. Today we're going to be talking about the issues of global warming. Let's jump right in. So, first off, we have to first understand what this term means, global warming, why IB is using it, and why we also hear the phrase global climate change, and what are the differences. So, global warming is referring to purely the Earth's average temperature is increasing. Throughout this unit, we're going to be looking at lots of data that suggests this. We'll also talk about why some people would find that controversial, but also why the data really is currently supporting that. Also, we're going to think about the overall changing of the climate globally. That refers to not just the average global temperature increase, but because of that temperature increase, we see lots of other changes, such as the ocean currents, wind patterns, changes in temperatures in local areas, changes in ecosystems, and that's going to also cause changes in society. So global climate change is referring to a much broader type of situation. Initially, to begin with, we're going to really be focusing on just the warming component and how that works and why it's happening. So that's going to be related to this term, the greenhouse effect. The greenhouse effect is called a greenhouse effect because of the way a greenhouse works. A greenhouse, picture a glass house. It's going to be a lot warmer, even in the wintertime, inside a greenhouse than it would be outside. And the reason is the light will penetrate in and the heat will get trapped on the inside of a glass greenhouse, causing a warming effect on the inside, even if it was cold. And this is all about trapping in of heat, this idea of the greenhouse effect. So let's put that into words, all right? The natural greenhouse effect refers to the fact that solar radiation will enter the Earth's atmosphere as short-wave, high-energy UV radiation. All right, that's this long, wiggly line that enters all the way past the different atmospheric boundaries and reaches the Earth. Then, long-wave, low-energy IR radiation will bounce off. All right, it'll reflect and bounce off, and it'll get trapped. Remember that greenhouse, that was that glass greenhouse in the previous picture? The Earth's atmosphere is acting like the glass component, where the atmospheric gases are what traps that energy or that low energy long wave radiation inside, right? That is natural, that process, and it keeps the globe warm. We are far enough away from the sun that we don't burn, but we still need to keep warm in order to have life on our planet. We would be an ice planet without some of this natural warming that occurs because of this trapping of energy called the natural greenhouse effect. So the problem is the humans, you and I included, we are enhancing the greenhouse effect's natural stuff. And the reason we are doing that is because we are changing the composition of the atmosphere and its gases. So it's normal for solar radiation to bounce off, re-radiate, and get trapped. But because the greenhouse gases that are involved in this trapping are increasing in their amount, this red part, notice that there's so much more of those here. That's causing a lot more energy to be trapped than normal, causing a higher amount of warming. To summarize that, more greenhouse gases, more warming, and that's what the humans are involved in. So what do we mean by a greenhouse gas? I'm going to abbreviate greenhouse gas from now on because it's too much to write as GHG. There's a lot of them, all right? And what they are gases that are really good at absorbing and emitting that infrared radiation. They are the things that are like the glass in the greenhouse that trap the energy and cause the warming. Some of them cause it more than others, but they are the gases that cause the warming. They are in different amounts in our atmosphere, and we're going to also throughout class be learning what kind of places and cause them to exist in the first place in the atmosphere. So in abundance order, water, yeah, is a greenhouse gas. And it's supposed to be up there. Sometimes there's extra water in the atmosphere, but it is the most abundant. The next most abundant is carbon dioxide. It's always been in the atmosphere, but it's gone up in there more because of humans. Methane, we're going to learn about that one in a little bit too. Nitric oxide, and then CFCs. So, you have this chart that you can jot down in your notes. It's got a lot of information. But the big idea here is these different things on top of how much exists in the atmosphere in abundance, they have different effects and strengths in how much they warm the atmosphere. We call that efficiency or strength of warming as a greenhouse gas, global warming potential. Think about it as if you were playing a video game, how strong the character was. This is the strength of the greenhouse gas and how it is warming. The higher the global warming potential, the worse the pollutant is for global warming. We normally hear about which thing the most in the news. Carbon dioxide. And that's because it's the one a lot of us think we could control a lot and to reduce. But it has kind of one of the lower global warming potentials compared to some of these other things like nitric oxide, CFCs, methane. Some of these other things that we don't hear about quite as often until this class, they are actually way stronger. But it is important to know there's not necessarily as much of them in the atmosphere, thank goodness. But one of the reasons why they're so strong is because they last a really long time in the atmosphere, and that's their lifetime. They just don't dissolve or disappear for a really long time. They just stay there. So let's learn a little bit more about this stuff, including this global warming potential. So for some basics in our next objective, we would like to know a little bit more about each of these greenhouse gases. We'll practice them in class. Water vapor really is getting into the atmosphere purely because of evaporation. But as it gets warmer, we're going to have more evaporation. But it's pretty natural to have water up in the atmosphere. Carbon dioxide is really getting up into the atmosphere because we're burning fossil fuels, those non-renewables. We're also causing more deforestation, which is going to cause more burning of plant matter and also less trapping of the CO2. If there's any natural volcanic eruptions, that causes CO2 to get into the atmosphere as well. Methane comes from decomposition. It can also come from waste of livestock and farming. It is also well known to be released accidentally from landfills. Nitric oxide is really much related to fertilizer production as well as burning fossil fuels. Oops. Very much though we hear about it the most from agricultural pollution. Lastly, we have our CFCs, which are our synthetic gases. These are usually aerosols that were related to refrigerants and cooling agents, like in hairspray or in refrigerators that were made for humans alone, and as we sprayed them, they got into the atmosphere. Since most of these have been banned, thank goodness. So in order to track how much and how bad these things are, we have this international organization called the IPCC. This was established in 1988 by the United Nations Environmental Program, as well as the World Meteorological Association, an organization, wow, mouthful. But this is involving 195 countries and 1,000 different scientists on a voluntary basis. So all of these data we're going to be looking at in class are really backed by many nations, many people, and many eyeballs are looking at them to get these data. Most of this stuff is headquartered in Switzerland. Fun fact, you don't need to memorize. But they put out assessments almost every year to give new updates and ideas of what's going on. So we're going to look at a couple of these different graphs. You should kind of summarize the trends. I do not expect for you to draw the graphs. All right, but the big one you should jot down is about CO2. There's some major trends in CO2, and IB wants you to know them. Since in 1750, during the Industrial Revolution, the world has had a ginormous demographic shift. We have a lot more technology, we have a lot more population size, we have a lot more money or desire to have a more economically developed country if we're not currently, and we're using natural resources and natural capital such as trees and other things really quickly. So what is the trend during this industrial period for CO2? To me, I don't know about you, it looks kind of like our population growth curve, which we call J curve or exponential. Right now, we look to see that we have this exponential burning of fossil fuels as well as exponential carbon dioxide increasing in concentration in the atmosphere. And that's very much the case. We have seen global trends, though, that have been over long periods of time based on ice core data, which we'll talk more about in class. These trends show that there have been fluctuations over thousands and thousands of years in the amount of CO2. However, the current levels beat those by far. So a lot of people says this is natural for CO2 to fluctuate up and down, but our concentrations right now are beyond these natural up and downs and the natural up and downs of the temperatures that match those. So that's an interesting summary statement that you might be able to add into your notes, but of course you should not draw the graph. We will be talking about in class that the different industries have produced these different greenhouse gases in different amounts, whether it's the energy sector burning fossil fuels, agriculture producing some of those synthetic gases. So different sectors of our society are producing these at different rates, and that will determine how we manage them. And related to that, we also can see that different specific parts of the energy sector are causing more than each other amounts of CO2. So that might be related to how much we're using those things. Are we currently switching between coal and natural gas, etc.? But we can definitely see all these non-renewable fossil fuels are related to the production of CO2, which is not a great thing. But over time, the only one of these greenhouse gases that has really decreased in use in the last, especially 50 years, is CFCs. And we'll learn that's because there's an international ban that has caused these to level out. Thank goodness, because they're one of the worst in global warming potential. Last but not least, there are some skeptics out there that will note that annually the weather will change. There'll be ups and downs in the weather. Similarly, the skeptics will say that there's ups and downs in the CO2 annually. Well, that's related to the time of the year. So we can see the overall trend in CO2 is this blue line, and the ups and downs annually are the red line. And if we think about the red line, why do you think the CO2 would decrease in the summertime? What are plants doing, especially when it's warm with a lot of sunlight? They're doing photosynthesis. And what does photosynthesis take out of the atmosphere? CO2. So related to this annual cycle is the amount of photosynthesis. And so there are ways that hopefully using some of these key trends that are annual, like if we could have more photosynthesis, we'd have a better situation with CO2. But currently, we do see an overall increasing trend, which is worrisome for global warming overall. We'll review greenhouse gases and some of these graphs in class. Great job, guys.